Hello, Tammy, and whoever is working on the program. Sorry, I don't know what your name is. I felt it might be easiest to answer your questions as far as what it is I'm looking for by just recording me walking through the lab and with the file that I sent you before. So this is the same schematic from the lab, as you can see here, with the power source being 4 kilohertz at 2 volts RMS, a 25 millihenry inductor for L1 and a 50 millihenry inductor for L2. Now your first question was, please provide the values that should be shown in the two ETS boxes. What I'm looking for to be displayed there are going to be the two values that are being displayed on the ammeter and the voltmeter. I am not sure. I've looked at the spreadsheet from the test ETS, and I have never seen any data point on that spreadsheet that shows a value that is reflective of what is being displayed on the multimeter. I know I've seen where you are able to get the exact values that are being displayed to be able to send back over to the lab. So basically, on this top box, I am looking for the value from the ammeter, and for the bottom box, I am looking for the value coming from the voltmeter. Hopefully that explains that question. The next question you had was, there's no data from V1 here in the formulas. We are supposed to be using the measured values of voltage and current from procedure 4. So this value of voltage, this value of current, that would be brought over from the ETS. The participant will use those two values in this formula to determine what the inductive reactance is. It's extremely similar to lab 11965. Once they calculate that, they should enter that value here, use that value in this formula in procedure 6 to determine what the total inductance is for the circuit. After that, they were supposed to be using the two values from the original lab. I guess I can just pull up at the top here. L1 and L2 used in that circuit is this 25 millihenry inductor and this 50 millihenry inductor. So that is from the two values of inductance. Hopefully they should be relatively close. The value that is calculated in procedure 6 using this formula, or excuse me, this formula should be relatively close to the value that is calculated here using this reciprocal formula using 25 millihenries and 50 millihenries. Now, this time the parameter of the frequency is supposed to change down to 3000 hertz. With that higher frequency, the inductive reactance is higher, so we'll have a lower current. So if I de-energize the circuit, change those parameters to 3K, you'll now see that we have a lower inductive reactance and thereby having a higher current flow. Now it's up to 6.642. It's finally settled down at. So in that last procedure that you asked, basically, once again, I would like to see these two values, the 6.42 and this change to 1.98 volts, I would like to see those two values inserted in these two boxes once the data is sent over. And that was the last of your questions. Hopefully that answers your questions. If not, if I need to type out anything else, please let me know. I'll be more than happy to do that. It just seemed like it might be the easiest way to once again explain this by just recording the steps of going through it.